Subscribe to Tech Talks and hit the bell icon to get notifications about coolest and latest engineering technology in the first place. The most important thing before doing any MATLAB programming is paper pencil work. This is because if you don't have any clear idea about what you are going to do, you cannot implement it in MATLAB. As you can see, I have also done the same. The next important thing is fixing the parameter. This is important because the values that you are going to put in MATLAB is very important. Until and unless you put this value and don't have any clear idea about what will be the expected result, your answer will not match. I have taken some definite parameters as per my convenience. You can take your own. Once you have done with these two steps, you can now handle MATLAB Simulink and do whatever circuit you want to do. Here an example of three-phase induction machine is shown. Don't skip any part of this section as you can miss some vital information. So stay focused and enjoy the video. So this is MATLAB. So here we will be doing a simple MATLAB simulation of three-phase induction machine. So this is a three-phase induction machine. From where you will get it? You will get it from this Simulink. We will go to SimSpace, the Simscape. There, specialized technology. Then machines. You click on machines. You will get this one, asynchronous machine SI unit, right? And the other things, that is a source. I've taken three sources. You will be getting it over here, electrical sources. Okay, so this is a asynchronous machine. If you click on there, the properties will pop up. So it is a wound rotor, that means the rotor side is accessible. The mechanical input is torque, a reference frame is synchronous. Parameter, I have put the parameters as according to my convenience. You can put different parameters also according to your my machine or whatever you want to plot. You just see that this slip, in this part the slip should be 1 while starting. They should be taken care of, and the other things are okay. So these are sources. So this you can see over here that the parameter I have put voltage line to line as 415 volt. So if it is in 415 volt, then the phase voltage would be 415 divided by root 3, that is nearly 240 volt phase voltage. So the peak of the phase voltage would be into root 2, that is 339 volts. So I have put 338 over here. I can put 339. 50 hertz, no phase changes there. And the other part I will be putting it as 339, but a phase delay of minus 120 degree. Here also phase delay of plus 120 degree. Then I would connect it with the motor over here. So going over here, this will be going over here, and the star connected supply. So the other parts are connected to neutral and it is grounded. The rotor part, that is this ABC, should be short circuited. Now a small amount of torque should be provided over here. So I am putting it a value of initial value This is the bus selector. This bus selector, I will be putting it over here so that I can take the uh, readings of the motor. So if you click on this bus selector, so you can see over here that the rotor measurements, stator measurements and mechanical measurements are all over here. So we will take two things. One is the mechanical rotor measurement and mechanical torque measurement. Okay, so the upper part is speed and the lower part is torque. Okay, so I will take a scope from here. Scope and I will be making two to three inputs and the layout 3. Okay, so it is done. To measure the voltage, phase voltage, we have a voltage measurement. So the positive is connected to the phase and the negative is connected to the ground. Positive is connected to the line and the negative is connected to the ground. So this will give me the voltage, phase voltage. And for current, I will be connecting one over here. So it is done. Now we'll just see that what torque and speed appears over here. So both are connected to this one, and we'll just play the run button. It is compiling. Simulation is being done. 27%, 41%. So let us see. So you can see this is the scenario. Since it is just keep a look over here, the parameter I have given here a 50 hertz supply, 50 hertz frequency. So the speed of the motor will be around 157, but less than 157 because 157 is the synchronous speed, so it will be less than 157. So let us check. So in this condition there is a steady state. So you can see that this is less than 157. Also the no load torque, this is a no load condition. The no load torque is almost equal to 0. So let us check. The no load torque is equal to 2 Newton meter. Right, now suppose we want to calculate what is the input power, what is the output power and all those. Just take a scope and connect the voltmeter and then an ammeter of the same phase voltage, phase current. Now if you click it over here and you will be getting a waveform of voltage and current. So just take up this maximum value of the voltage and just take up this maximum value of this current. So from maximum value you can easily calculate the RMS values, and also you can calculate the phase angle between this one, between the voltage and the current. As you could very well see that for calculating the phase voltage, you just zoom it in the horizontal axis, that is this one. So it is cutting, the voltage is cutting over here, that is at 0.9 seconds, and the current is cutting here, that is in between 0.904 and 0.905 seconds. So from this part you can easily calculate what is the phase angle bit of voltage, input voltage and input current. So when you have got the phase angle of input voltage and input current, and you have got the RMS value, so 3 V phase, I phase, cos phi, you can easily calculate the input power. Now if you want to calculate the output power, so that also you can do, because output power is equal to torque into speed. So here you are getting torque and speed both, so you can easily calculate the output power. So all these are regarding machine. Now what will happen if we increase the load torque? So for increasing the load torque, we will take the, here the step time we will be defining at 0.015, because you can very well see that at 0.15 you can define anything, but it should be in this stable zone. It should be in this stable zone. You can even define it as 0.25 also, because at 0.25 the machine is in stable zone. So let us define it as 0.25. The final value will be 20 means 20 Newton meter. So let us run this one. Okay, now you see over here, if we analyze this part, at 0.25 the load torque has been get load torque of 20 Newton meter is given. So what has it done? It has reduced the motor speed and it has increased the torque produced by the motor. Okay, so in this way you can play around with this circuit. Thank you.
Comment below about how you like this video. Check out the links in the description box about more such videos. Do click the like button if you like the video. If you are new to this channel, subscribe Tech Talks and don't forget to hit the bell icon.